Okay, good morning all. I am audible, I think, now.
Yes, sir, you are audible. Good morning,
I am
sir.
going to share my good morning. I am going to share my screen. Let me know, is it visible to you all or not?
Visible, sir.
Okay. So today actually I am going to take a lecture on tree. I am continuing with my yesterday's point where we have stopped yesterday. So yesterday we have learned, or we have actually started the non-linear data structure, that is tree. Okay, and we have learned the very basics of tree. We we discussed about what is actually the tree, how it is being maintained, the various elements, various nodes in a hierarchical form. We have seen its definition, in basic definitions of the terms that we are going to use in this unit, as well as most probably in the coming unit also. We have learned about the characteristics and the applications of tree, and then we have initiated the binary tree. I think till that point we have covered. Please confirm me.
Yes, sir.
Yes, sir. Binary tree के बारे में कुछ
So binary tree
information.
we have started. So can anybody tell me what is a binary tree?
Which contain zero to
Which
two
contain
children.
at most two node, at
Very good.
most two children.
Very good. At most two children's. Good. Which contains at
Children
most two children's. It means it could be either zero, or it could be either one, or it could be either two children. But not more than
maximum
two
two.
children's it will have. Okay.
Maximum
It,
two.
it will not have more than two or maximum two children's. Good. So I'm repeating the definition, that is a binary tree. T is either empty or such that T has a special node which is a root node. Always a tree must have a root node. Okay. Now a T has two sets of the nodes. One is left subtree and one is right subtree. Okay. Both are individually a binary trees. Like in that you are seeing in this example, you can see that I am having a root node, that is A, and the other subtrees are left subtree and the right subtree. Like this, B, B, E, G is a left subtree. Similarly, C, F, H, I is also a right subtree. Again, in that B is a root, and this one is the left subtree, and this one is the right subtree. Again, in that this is a root, and this one is its right subtree. So there is no left subtree in that case. So you see that here there is no left subtree. It may also possible. Okay. So that is what the definition of binary trees. So we will now learn about the various operations and the characteristics of the binary tree only. Okay. We will focus on binary tree in this unit only. So now tell me, is this a binary tree? The diagrams you are able to see in on your screen, is this a binary tree?
Yes, it is a
Yes,
binary
sir.
tree
Yes,
How
sir.
because
many
it
nodes are there in this?
contain one
One.
children.
How many nodes are there?
One,
Overall nodes.
Two.
Two
one.
nodes are there. Who says
Why?
one? Who says one?
मैं सर सर कैसे
How
two
many
notes
nodes
कैसे
are there? How many nodes are there in this?
notes? Ah, two.
Then now tell me, is it a binary? Is all these are binary trees also?
Yes.
Yes, sir.
Yes, sir.
All these are also a binary tree. Okay. So like these are the specific cases. Like you can see now how many binary trees you can make with two nodes. This is the answer of this question actually. If you have like this particular question, if you will see, then this is the answer of that question. Like how many different kinds of binary trees you can make with the two nodes. So two nodes, I can only make these two binary trees. Okay. Similarly, with the help of three nodes, how many binary trees you can make?
With the three notes.
With three nodes, how
Five.
many binary trees you can make?
5.
ये जो आपकी स्क्रीन पे these trees are visible, these are the trees which can be made with the help of 3 nodes. Okay, can any other combination is possible with these 3 nodes that makes a binary tree? Can anybody suggest me any other combination like that could be there?
थर्ड, हेलो सर,
हाँ, hello.
सर नंबर थर्ड पे उसका रिवर्स कर दे तो?
Reverse order, very good. You need to ask everything, whatever in your mind you need to ask. You are saying this one?
यस सर, यस.
Okay, but it is not a tree actually. In tree, always the root node will be at the top. Okay?
सर
Tree
ये
में-
ट्री कैसे हो गया? क्योंकि ट्री में तो सर टॉप टू बॉटम जाते हैं ना, और इसमें तो
मैं वही बोल रहा हूँ बेटा,
ओके
मैं
ओके
बोल लूँ
ओके, हाँ हाँ
आपके
ठीक,
आगे और
ओके सर.
Okay, this is not a tree actually. This is in a tree we must have a root at the top and then we must have their children and so on. So in this way there will not be the 2 roots in a tree. Like if you are saying this is a tree, but it is because there are 2 top nodes, so it means there are 2 nodes, 2 root nodes. It is not possible actually. Okay. Any other thing in your mind? Anyone must have something in your minds. कि क्या कुछ और combination बन सकता है इन 3 nodes के अलावा?
Sir, mirror image of third one.
Mirror image
Like
of third
mirror
one
image.
means, like suppose you are saying
Like-
ki A, B, C, and now you are saying ki A, C, B.
CB. Yes, sir.
तो सर ये तो एक ही हो गया.
That is same thing, but we are coming on to that actually. These are similar kind of trees. हम अभी definition पाएंगे similar trees की जो हम पढ़ेंगे. Okay, these are similar trees actually. Structure is similar in that case.
मेरे पॉइंट ऑफ व्यू से तो सर कोई कॉम्बिनेशन नहीं बन रहा.
Thank you very much. अब बाकी दूसरे बच्चों से पूछ रहा हूँ मैं कि anything else anybody wants to ask? क्योंकि ये तो अपना जवाब दे चुके हैं, अब हम बाकी से पूछ रहे हैं. बताइए. Anyone else and anything in their mind? क्या और भी possibilities हो सकती हैं? A structure in that case it is same, na? Like if you will see that these are all different structures. So I am talking about structure. You can say. Can any other structure I have with 3 nodes? No, I cannot have it. So let's say
सर यदि हम बी को ये फोर्थ वाला इसको बी में बी नोड है उसको रूट बना दे तो
बच्चे स्ट्रक्चर का क्या मतलब होता है?
चेंज ना हो, स्ट्रक्चर को चेंज थोड़ी कर.
तो स्ट्रक्चर तो वही रहेगा ना बेटा. आप बी को ऊपर ले जाए, चाहे सी को ऊपर ले जाए, चाहे ए को ऊपर ले जाए, डी को ले जाए, चाहे एफ को ले जाए, किसी को ले जाए, स्ट्रक्चर तो 3 नोड से यही बनेगा ना, ये वाला.
यस सर.
डाटा कुछ भी हो अंदर, डाटा इज डजंट मैटर. दैट इज व्हाट आई हैव ऑलरेडी सेड इन दिस एग्जांपल कि इफ आई एम स्वैपिंग दिस बी एंड सी, then their structure is same, so I cannot say that some other tree is there. Tree is same. Okay, so this is the various examples of binary trees that could be there, and we will have these kinds of tree also. Okay, so instead that this could also be a binary tree. Is this single node is a binary tree? Tell me now. Is this a binary tree with one node?
Yes, sir.
Yes, sir.
This is also a binary
Yes, sir.
Yes sir, it is contain one child.
binary tree. Okay, so now properties of binary tree that are very important. If a binary tree contains m nodes at level n, now you know what is level. अब मुझे ये सब terms बताने की जरूरत नहीं पड़ेगी. I think you must know before I have. That's why I have already discussed all the terms previously. So if there are m number of nodes at the level n l, it contains at most 2 m nodes at the level m plus 1. Is it clear? Do I need to tell you? Like these properties are very important. Like based on these, there are MCQs actually. MCQs may be there based on these properties. Directly in the GATE examination also, MCQs may be asked in any other कोई भी PSU examinations or any other competitive examinations or any other interview. Questions will be asked based on these things. Okay, and these on these terminology also. ये जो terms आपने पढ़ी हैं ये सब बहुत important है. कहीं से भी किसी भी तरीके से जो भी न्यूमेरिकल टाइप कुछ बनता है वो इट इज डेफिनेटली बेस्ड ऑन दीस टर्म्स ओनली. So now tell me, is it clear to all, if a binary tree contains m nodes at L level, then it contains at most 2 m nodes at the level L plus 1. Next level पर just double nodes होंगी हमेशा, maximum at max. Is it okay?
Yes, sir.
Yes, sir.
Yes, sir.
Let's take an example of this one. This one, okay. Okay. Now this is my level 0. This is my level 1. This is my level 2. This is my level 3. So if if at the level number 2, how many maximum nodes could be possible?
2.
At level 2, how many maximum nodes are possible?
4.
4.
4.
Okay. Now at level 3, how many maximum nodes could be possible?
8.
6.
8. 8. For every node at 2, there may be at most 2 childs. Yes or no? For
Yes,
every
Rohit.
node at the level 2, there must be there may be at most 2 childs at the level number 3. That's why the number of the nodes at the next level will be double, at most double. Maximum we are talking about. It could be less than that also, but it could not be more than that. That is what the property says. Okay. Now, since second one is, since the binary tree can contains at most one node at level 0, the root node, it contains at most 2 L nodes at every level L. Is it also true?
Yes, sir.
If I will talk about the level, like that is what I have discussed already. At like this is suppose level number 1, the maximum number of nodes क्या होंगी? 2 into 1. Similarly, if I am talking about 2 level, so maximum number of the nodes
4.
will be 2 into 2. Okay.
4.
Then maximum number of the nodes at this will be 2 into 3. So 2 into L. In general, if the level is L, the maximum 2 L nodes can be there in a binary tree at level L. That is the second property. Now, maximum number of the nodes in the binary
Sir?
tree could be, yes, yes.
So second point is contradicting first point.
No.
Yes, sir.
Yes,
So if
sir,
you are
because
saying
you told
12
that there
node-
would be 8 nodes on the third level, and now you are saying there will be at most 6 nodes at the third level.
Just a minute. It contains at most 2 L nodes at level L. Two L नहीं है, it is actually 2 to the power L. Change it. I have
Yes, sir. It will be 2 to the power L. Yes, sir.
sorry. Discard. It is actually in this PPT. It is power. The ratio power option is not available, so I am putting this particular sign over there. Okay. So 2 to the power L nodes must be there at L level. Is it okay now?
Yes, sir.
At any level L, so let L at this is also true for the first level. You can see now, because it is labeled as 0, so 2 to the power 0. Okay, level 1, so 2 to the power 1. Level 2, 2 to the power 2, 4 nodes maximum. 3, 2 to the power 3 nodes. Is it okay?
Yes, sir.
Now you tell me the formula of maximum number of nodes in a binary tree having depth d.
2 to the power D. This one.
No, having depth d. Total number of the nodes I am asking in binary tree. Like suppose this particular tree is there. Okay. So how many maximum number of nodes it could have? This
Sir,
tree.
2 to the power D plus 1. 2 to the power D plus 1.
D is the depth of this. Okay. Yes or no? Just try to find out this. Depth, I am talking about depth. One option, when someone gives us 2 to the power D plus
No,
1.
sir. It will be like power D plus 1. 2 to the power D plus 1. In power plus 1. Sir.
Depth 4.
Depth का फॉर्मूला क्या था?
Level plus 1.
Maximum level plus 1.
तो लेवल
2 to
कितने हैं
the
इसमें?
power 5.
लेवल कितने हैं
3
इसमें?
level है. 3 plus 4. 32 nodes.
Now find out how many maximum nodes could be there in this tree. 1, 2, 3. Like you
फोर
need to
तो
add
डेप्थ
all
हो
these
गई
actually. You need to add all these. This is 1, this is 2,
32
this is 4, this is 8. तो कितनी नोट बनी
16.
अब?
2 to the power 89
Is it clear to all or not what I am doing over there?
सर ये
Sir, there
1
should have
2
been 15 nodes.
Yes,
Sir, ये-
that tree must, yes, that tree can have at max 15 nodes.
सर ये
now
डेप्थ
try
है
to
इसकी
find
1
out-
2 3 4
क्या?
1 सर ये डेप्थ है इसकी 1 2 4 8
That
Nodes,
means number of nodes हैं ये.
हाँ
Number of nodes at that level. Level number 0 पर maximum.
Sir,
1
2 to the power 4 minus 1. There are
Yes.
4 number of levels.
2 to the, तो नहीं, there are 3. हाँ, तो depth is actually what? 4.
4 है ना sir,
Depth is
that
4
yes.
ना?
हाँ.
So 2 to the power d minus 1. That is the formula. Total number of the nodes you can say for any like now suppose I will add one more level in that. So one more level it means ki 2 to the power 4 16. Okay, then total number of the nodes will be plus 16, it is 31. Okay, now 31 will also be there. Like in that case depth will be 5. So 2 to the power 5 minus 1, 32 minus 1, this is 31. Is it okay? Is it clear to all? This formula you need to learn actually.
सर रुको सर डेप्थ अगर हम 4 रखते हैं 2 to the power 4 16 15
Everyone is it clear?
लेवल 4 पर सर इसके 15 सर इस फॉर्मूले को प्रूव कर सकते हैं सर 2 to the power डेप्थ अगर 4 रखें तो 16 minus 1 15
प्रूफ ही किया मैंने बेटा, ये यहाँ जो न्यूमेरिकल वैल्यू की मैंने बात करी वो प्रूफ ही किया मैंने. Okay.
फिर मैं खुद एक बार खुद करके देखूंगा.
So maximum number of the nodes in a binary tree will be 2 to the power n minus 1, where n is the depth of the binary tree. Is it clear to all now?
Sir,
Yes.
sir, please repeat the first point again.
If a binary tree contains m nodes at the level
Yes,
number n, then it can contain at most 2m nodes at the level next level. So like suppose in that case you are saying, let us take this example, okay? Like suppose this is level 0, this is level 1. So at that level suppose one node ही यहाँ पर है available, okay? इस level पर कितनी nodes available अभी इस particular tree में?
1 node.
So now at next level how many maximum nodes could be there? At next level how many maximum nodes could be there? At level
2.
2, because that node can have at max 2 childs. That is what it is saying. Suppose that at the level 1 I am having m number of nodes, then next level पर I can have at most 2m nodes. At most 2m.
Okay
Again,
sir, मतलब previous level पे जितने भी number of nodes होंगे उसका double next level में होगा.
maximum होगा. Maximum बोल रहे हैं, again at most बोला है वहाँ पे भी क्या लिखा है हमने? At most देखिए यहाँ पर at most. Again, because again it may not have any node. Like now, suppose now I am talking about the level number 2. There are how many nodes? 1 node only. Now at next level, how many maximum nodes could be there? If it is 2 now, so like at level 2 we have now 2 nodes right now. Okay, so at max I can have 4 nodes.
4.
Okay, but right now in this tree there is 0 also, because they both have 0 children. So it could be 0, it could be from 0 to 2m actually. It could be from 0 to 2m. Is it okay?
Sir, if we are looking in this particular example, then theoretically we can say that it is going to have 4 nodes. But as we see that on the second level also we have 1 node only. Then also we are going to have 2 maximum nodes in its further level.
Yes.
So sir, how we are saying that it is going to have 4 nodes after the second level in the last tree?
This example you are talking about.
Yes sir, because as we are seeing last level has only 1 node.
1 node. So nahi, I am assuming that node is also added now.
Okay, so sir we are saying कि हम जैसे जैसे लेवल बढ़ाते जाएंगे वैसे वैसे तो नेक्स्ट लेवल के जो नोड्स है वो डबल होते जाएंगे, हो
मैक्सिमम
सकते
डबल,
हैं,
मैक्सिमम
हो
डबल,
सकते हैं.
यस यस, मैक्सिमम डबल
Okay,
होगा।
okay sir.
Yes, sir, but according to this example, it could be two only.
हाँ,
because it is binary tree.
according to this particular example, it is two only, at max two
Yes, sir.
only.
सर ये
And
कंडीशन
sir,
ओनली बाइनरी ट्री में अप्लाई होगी ना कि नेक्स्ट
डेफिनेटली
लेवल
मैंने बाइनरी की प्रॉपर्टीज ही बताई हैं बेटा।
पर
sir,
अब जो भी हम डिस्कस करने वाले हैं दैट इज ओनली फॉर बाइनरी ट्री, नथिंग एल्स। हाँ पूछिए।
sir, here we have written that binary tree with two children. But in the first example or in the last example of this, we could see that there are only one children,
दिस
a
वन,
single parent. No, sir, below example. So we have written a binary tree with two children. But in the third image, we could see that there is only one parent and it is having two children. But in the rest of the example, there is a single parent and it is succeeding by a children.
what it is writing over there is with respect to the root node, they are saying for root node two children are there, like this is one children, this is two children. You need not to confuse with that, I will change over there, okay?
Okay.
आप इससे कंफ्यूज मत होइए, मतलब टू चिल्ड्रन का मतलब ये है कि लाइक जो रूट नोड की यहाँ बात कर रहा है दैट इज ऑल। बाकी यदि इसको आप मतलब हम इसको चेंज कर देते हैं बाइनरी ट्री विद थ्री नोड्स, दैट्स इट। एक्चुअली मैंने पढ़ाया भी आपको वही था, बाइनरी नोड विद थ्री नोड्स। इज इट ओके नाउ?
Yes, sir.
Okay, now coming on to the types of binary tree. Types of binary tree, again it is very important. Strictly binary tree, complete binary tree, full binary tree, यहाँ दो लिखना भूल गया मैं। One is extended binary tree and one is skewed binary tree and similar and add to like, okay, so some specific types of binary trees now we are going to learn about. So first of all, strictly binary tree. What does the strictly word means? Strictly के word का मतलब क्या होता है? What is the meaning of strictly? Strictly, do not write the definition first, just tell me what is strictly.
जनरल लेवल से बता सकता हूँ
सर सारे
अंशुल बोलो क्या बोल रहे हो आप?
सर जो सारे नोट्स हैं उस पे सर मैक्सिमम चिल्ड्रन अलॉटेड हो सर।
No,
compulsory.
strictly binary it means binary का मतलब binary हो गया। Binary, strictly binary means exactly two nodes, two childrens. Right now we are asking about the binary tree. In binary tree, what we could have 0, 1 or 2. But in strictly binary tree, I can have only two children. So 0 is by default there because every leaf node must have 0 children. So strictly binary means there is only either 0 or 2. That's it. That is known as the strictly binary tree. Okay, no concept of one child is there. So if every non-leaf node in a binary tree has non-empty left and right subtrees, okay, then such a tree is known as a strictly binary tree. If every non-leaf node in a binary tree has non-empty left and right subtrees, then such tree is called the strictly binary tree. Is it clear to all now? In short, I can say that if the tree, every non-leaf node must have two children. Like you can see in this particular diagram also, except H, I, E, F, G, which are the leaf nodes, every node must have two childs. And all the leaf nodes by default have zero childs actually. That's why we have to include 0 here, otherwise it is only 2. Is it okay? Or if I will talk about in terms of degree, then the degree can be like for any node, the degree can be either 0 or 2. That's it.
Maximum 2.
Not maximum 2. Maximum 2 is what is a binary tree I'm talking about. Now I'm talking about strictly binary tree. So it is either 0 or 2 only, never 1. Maximum 2 का मतलब 1 भी आएगा उसके अंदर. Okay, so degree can be no node can be of degree 1 in that case. That is, that particular tree is known as strictly binary tree. Okay, is it okay?
Okay, sir.
Definition is clear to all. What is strictly binary tree? Tell me yes or no at least.
Yes, sir.
So a strictly binary tree with n leaves always contains 2 to the power 2n minus 1 nodes. That is also a formula for that strictly binary tree. So how many leaf nodes are there in this tree?
5.
5 leaf nodes are there, and total number of nodes are
9.
9.
that is 2 into 5 minus 1. That is 9 nodes.
9.
This is the formula for strictly binary trees nodes. Okay. Now next one is complete binary tree. This is again important. Now two terms I want to explain simultaneously, actually, complete and full binary tree, because they are almost related to each other. So complete, first look, have a look on that diagram. Complete binary tree diagram देखो सबसे पहले आप लोग. Okay, and now full binary tree का diagram देखो आप लोग. So can you like trying to find out the difference between these two, full binary tree and complete binary tree? In complete binary tree, you can see that like I am having a tree with the nodes, and at the last level, all the nodes are left aligned. Okay, left aligned means ki, please listen carefully. Left aligned means ki once I am trying to find out, like I am trying to put the childs of a particular node, then firstly I need to put the left child, and then I can put the right child. Okay, that is what the left, as far as left possible, this particular means left aligned means actually. So now tell read the complete definition of complete binary tree. A complete binary tree is a binary tree in which every level, except possibly the last one, is completely filled. Now you can also see that at before last level, all the nodes have been completely filled. Okay. Now at the last level, what happens actually? All the nodes must be as far as left possible. Okay, it means left aligned. Like suppose I am trying to fill, like I am trying to give you another tree. Now you tell me whether it is a complete binary tree or not a complete binary tree. Is it a complete binary tree?
No, sir.
No,
Why
sir.
not? Why not?
Sir, because the nodes are not left aligned.
Left aligned.
Sir,
Very good.
एक
Now-
साइड में
now-
एक साइड की जनरेशन में प्रोग्रेस होनी चाहिए.
Now tell me, is it a sorry? Like now, is it a complete binary tree?
No, sir.
No, sir.
Why not?
Sir, it is right aligned.
Right and right.
Why?
Right
This is
side.
left child. This is left child. This is not a right child.
सर लेफ्ट वो राइट की तरफ तो प्रोग्रेस हो रही है सर. लेफ्ट की तरफ तो नहीं, लेफ्ट की
Sir,
तरफ
it is
होनी
on
चाहिए.
the
जो चिल्ड्रन है वो लेफ्ट की तरफ होने चाहिए.
ठीक है, अब आप चुप हो जाओ, दूसरों को बोलने दो बेटा एक बार. हाँ, कोई और बताना चाहे क्यों नहीं है बेटा ये राइट सब ट्री, मतलब कंप्लीट बाइनरी ट्री?
sir, as it is on the right node of, means it does not depend upon the arrow, means it is on the right node of above.
Not getting you. Can you repeat?
Sir, it's like means there are two nodes above, means right and left. So it is on the left node. So it is not the
Complete binary tree.
yes, sir.
The reason is that first of all I need to fill the childs of left parent also. Okay, so suppose I am going to put the node of this particular child, Okay, but before that, this particular node's children must be completed. So first of all this, and then this, तभी इसका turn आएगा, otherwise इसका turn ही नहीं आएगा actually. Okay, so that is what the complete binary tree means. Now is it clear to all now?
And
Sir,
so
if
why
we
the
have-
above example?
Because in that we have filled this node completely, it is okay. Till that point it is okay. But before going to the right of that particular node, it must be complete, left must be completed.
Okay, sir.
है ना? Like now just like अब देखो एक बार, मान लो मेरे पास कोई भी tree है. So first of all I need to fill the left part. Left part I have filled. Then I need to go on to the right part. अब this level is completed. Now if I am going on to the next level, then first node will be at that point. Second node must be at that point. Third node must be at that point. Okay, and then so on. In this way we need to proceed. Now this level is completed. Then at next level I cannot do this one, because first of all this particular node first left needs to be filled. Okay, from
Sir, is
first
it
right
compulsory?
from
Yes.
first node I need to proceed, and left right direction I need to proceed.
So whichever node we take, we need to proceed with the left hand side.
Definitely
If from
not
the
left.
same node, if we proceed from the right hand side, then it is not a complete binary.
Yes, it is not a complete binary.
Sir, is it compulsory to fill the left node completely? Means in the
In complete
exam.
binary, in complete binary tree, it is compulsory.
Sir,
Sir,
if you
you
take in the example, the second example,
Yes, this one.
yes, sir, this one. Yeah, in the second left root node, we can say left node, left
This one?
subtree. Yes, if we add only one left node to it and one left to the right node, then also is it not a complete binary tree?
You are saying this one?
Yeah, and this also left. Yes.
No, no, it is not a complete binary because its right is not filled completely. मतलब
We
this
have to fill the left completely.
Yes, this particular node must be complete first.
सर आपका कहने का मतलब है कि पहले लेफ्ट साइड में जो पेरेंट्स है उसके चाइल्ड फिल होंगे, तब राइट का नंबर आएगा.
Yes, definitely.
Sir, if we don't make the right node, we just continuously start filling the left node only. We don't create a right node.
Then
Then
this
also-
one must be. ऐसा कुछ कह रहे हैं आप?
Yeah, but there must be a right node to the second, first left node, sir.
Before coming on to the next level, previous level must be completed. That is also the case in that.
Okay, so the root node also has need to have two nodes, first left and then right.
Any node next level will be start only after the completion of the previous level. That is also is there. You just read the definition. Complete binary is a binary in which the level in every level except possibly the last one is completely filled. Okay, last level से पहले वाले सारे level fill होने चाहिए, तभी आप next level last level पे आ पाओगे, next level पे जा पाओगे. And
So,
then
sir,
all the nodes are. I need to change it actually. Yes, you just asked all the nodes. And
So, sir, if you know, each node has to have its left node, and if it is a left node, then it has to be completely free. Free what? Filled.
filled. Definitely, it must be completely filled.
And before that left node, in the above node, all above node has to be completely allocated.
Definitely.
Okay, sir.
Okay, now coming on to the next one, that is a complete binary tree has at most these many nodes at every level. That is already we have learned in the binary tree. That is the same. Is it clear to all now? Okay, at most nodes at any binary tree, whether it is complete, whether it is full, whether it is a strictly binary tree, whatever it is, the formula remains same as it is. Now, depth of the complete binary tree with the n nodes is this. This is a formula actually. That is again a very important formula. Depth of the complete binary tree with the n nodes is given by dn is equals to log. This is actually base 2. Again, I am not able to make it subscript. It is base 2. Please read it as log n base 2 plus 1. Is it clear now? जब भी आप इसको पढ़ें तो log base
log 2 base n.
Okay, log. Okay, so now suppose I have also taken an example in that. Suppose I am having n is equals to 1000, 10,000, 1000, sorry. So total number of nodes are suppose 1000. Then how like the depth of that complete binary tree will be 11. You can calculate with this log 2 1000 to 2 to the power 10. So log base 2 Actually, you can read it. I need to write it again, and I will save it. Okay, so log base 2, sorry, base 2 n plus 1. So now tell me what is the value of this? Log 2, 2 to the power 10. Base 2,
2 base 2 10,
10.
10.
it is 10
And
actually.
log n base n equals to 1.
So that's why I have said over there is it is 10. 10 plus 1 it is 11. So if suppose I am having 1000 number of total nodes in a complete binary tree, so the depth of that complete binary tree will be 11. Is it okay?
So, sir, we can't have a single right-hand side leaf node in the complete binary tree.
No, 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 no.
Okay, sir.
Okay. Now coming on to the full binary tree. Definitely with the help of this diagram, you can see that it is full. Full means it is completely filled. So at every level, maximum number of nodes must be there. Then that particular tree is called a full binary tree. Now you see that at level number 0, maximum number of nodes are there. So every level is completely filled actually. So then in that case, we can say it is a full binary tree. Is it okay? Full binary tree must have to the power this nodes at every level. That the line is sufficient to explain this full binary tree. Is it okay? Yes or no, please?
Yes, sir.
Yes, sir.
Difference is clear between complete binary tree and full binary tree because a maximum in interview the difference between the complete and full binary tree is being asked actually with the students, and
Sir,
definitely they
ये मुझे
be
point
not
clear
confused.
नहीं है. A full binary tree must have 2 to the power 1 nodes
To the
at
power
every
L
level.
nodes.
n है. At every level 1. Oh, अच्छा L है सर ये.
मैं बोल रहा हूँ आप सुनते नहीं हो बेटा. जब मैं बोलता
सर
हूँ तो
सुन
आप
रहा हूँ.
सुनते नहीं हो.
यस सर, अब सही लग रहा है.
नहीं आपके सही लगने से कुछ होता नहीं है वैसे. Okay.
Sir, for the first node, we are going to have one node only.
For the first level, there must be 2 to the power 0. It means one node only.
So we are having for the root 2 nodes. After root, we have 2 nodes.
Yes, it is 2 to the power 1.
Okay, sir. Okay.
2 to the power 1. Is this a full binary tree? Can anybody tell me? The diagram I have just drawn. Is it a full binary tree?
Yes, sir.
Yes, sir.
Yes sir.
Definitely it is a full. Is it a complete binary tree?
Yes, complete भी है.
Is it a complete
Yes, sir.
binary tree? Yes or
Yes,
no?
sir.
Please fast.
Yes, कह सकते हैं. Complete binary tree है.
Okay, tell me. This one is the complete binary tree?
Yes, sir.
Yes sir.
So
Yes, sir.
full
Because
binary tree,
full
full
binary
binary tree must be a complete binary tree. But complete binary tree need not
Is not a full binary tree.
necessarily
Yes, sir.
full
that will
binary tree always
यदि complete
complete binary
binary
tree.
है तो वो full binary tree हो ये जरूरी नहीं है, लेकिन यदि full binary tree है then it must be a complete binary tree. Next one is extended binary tree.
Sir,
Now
एक मिनट sir.
look at the diagram first.
Sir,
So yes,
So
Sir,
the previous slide,
full binary tree is also a complete binary tree, but complete binary tree not always full binary tree. Yes or not?
थैंक यू वेरी मच. मैं यही बोल रहा था बेटा, आप सुनते नहीं हो ना मेरी बात. मैं तभी बोलता हूँ आप सुना करो. आप बोलने से ज्यादा सुनने में ध्यान रखा करो. मैंने यही लाइन 2 बार बोली है बेटा, और आप लेकिन सुन नहीं देते मेरी बात.
Okay sir, अब सुनूंगा.
sir, a single node is a complete binary tree.
Definitely, because it is left aligned as far as possible.
Sir,
Is
but
it
we can't.
is it not following the all the properties of this complete binary tree? क्या वो इस complete binary tree की properties को follow नहीं कर रहा है?
Sir, if we calculate the depth of the single node, then it will
That is
be
one. That is one. like what is the relationship, like what do you want to say actually, depth और उसमें relationship क्या है, depth और complete binary tree में?
Sir, depth का formula is log base 2 into 2 की power n plus 1.
Yes, this is the depth of the complete binary tree with n nodes. तो one node है तो क्या होगा बताइए? Log 1 is
0.
0,
0,
the depth is
0, 1.
1.
1.
0 plus 1 1. So it means depth is 1, and a single node the depth is 1 always, because level is 0, the depth is 0 plus 1.
So for a single node, we can say
Yes.
it is left aligned.
Yes, definitely
sir.
it is left aligned.
But it can be right aligned also, sir. We
Yes,
are not
sir.
sure about it.
How
It
you
follow it.
now
It will
tell me,
change the
now tell me, this is a node, this is a leaf node. Is this a
Yes,
left
sir.
aligned or right aligned?
left aligned, sir.
How you can say?
So because we
It's
are seeing the
visible.
previous node, no?
No. So what is the like reason of not saying the left line to this single node? क्या reason है इसका कि left
So
aligned
we
नहीं?
don't know its previous hierarchy.
Similarly यहाँ पर मुझे नहीं पता कि अभी मैं डाल दूँ ये नोट तो बोलिए अब आगे आने वाले टाइम में किसको पता है बच्चे मतलब like how you can say that it will be a left aligned only with by only seeing the previous levels, how you can justify or how you can conclude that it is always a left aligned node. Now you know the definition of complete binary, that's why you are saying कि it is left aligned. But suppose before that, like before I have taught you what is complete binary, can you say that will be left aligned? Up to this particular example, क्या आपने कहा था कभी कि left aligned है या right aligned है? यहाँ जो भी examples में show कर रहा हूँ, like suppose in this, can you have like discuss this thing left aligned or right aligned? Who can say that it will not have any right child also 14 or like 5 or whatever it is? So single node is always a like follows this particular property. You cannot say that it will be a left or right child. अब इस लेवल के बाद क्या होगा मुझे क्या पता? यहाँ इस लेवल में भी क्या राइट है और लेफ्ट में कुछ होगा, आप आइडेंटिफाई कर सकते हैं? After that level, can you say something like it will always be the left aligned?
नहीं सर, नहीं कर सकते.
Okay, so just look at that. You are reading this particular definition and then you are concluding. But what I am saying is you just look at that particular diagram and then trying to find whether it is following the properties of this particular complete binary or not. This single node is following all the properties of complete binary or not. Look at that only. It is a binary tree in which कब क्या ये binary tree है? अभी तो आप ये बोलेंगे कि binary tree भी नहीं है, शायद हो सकता है इसकी 3 नोड हो. Yes or no? This may also be your conclusion. Still, if you have any doubt, you can ask, you can discuss. मैं ही बोला जा रहा हूँ, कुछ और बोलो कुछ. I am not getting your like understanding or not. Yes, anybody? Time is already 11. You need to like discuss or I need to end. What I need to do?
Okay, sir.
Sir, why we have a complete binary in left aligned only? Why not in right aligned?
That is a point of research.
Sir, like it's like a recursion. Like when I draw a recursion tree, it first complete the left array, then right array.
You just remember the merge sort. If you remember the merge
Yes,
sort,
sir. Divide and conquer. Divide and conquer.
merge sort mein what we do? We always start from left side.
Left side. A quick sort.
Dividing the like nodes into two parts. I always prefer the left first,
side.
left one first. And then I will be like at that next, like suppose 5 nodes हैं, so what I will do? I will break it into 3 into 2. Then 3 को मैं 2 into 1. Okay, then 2 को 1 into 1. तो मैं right side से prefer कर रहा हूँ ना हमेशा. Sorry, left
Yes,
side.
sir. Left side.
Okay. So can I move to the next? Actually, I need to stop now. I don't have so much of time. So complete and full binary we have started. Okay. So always try to look at the tree first and then find out whether it is following the properties of the complete binary tree or whatever you are trying to find out. जो भी prove करना चाह रहे हो उसकी properties follow कर रहा है या नहीं कर रहा है, तो आप सही से कर पाओगे. उल्टा मत करो, पहले definition पढ़ो और tree को मत search करो. Okay. Extended we will learn like in the next lecture. Extended, skewed, and similar trees. So for now it is okay. I am closing because the next class is about to start. Now I need to take the attendance. So, if you want to ask anything, you can ask. Otherwise, we can stop the class or you can leave.